I have seen many videos and everyone is like, first of all, you have to deeply understand what AI really is, use this tool, use that tool, master this or that, but nobody told me what the exact steps to learn AI as a complete course are. And today, we are not going to talk about the rubbish stuff, but the actual roadmap of learning AI as a complete, powerful course. And let me tell you this first, people are selling these courses for hundreds of dollars, but we're going to explore it for free. So if you're serious about learning AI the right way, let's get started. Step 1. Basics. Look, we have to start with basics. Don't jump around until your basics or fundamentals are clear. If you still lack some knowledge about the basics, it becomes a weak foundation on which we're trying to build our empire. Think about it like this. You wouldn't try to build a house starting from the roof, right? You need a solid foundation first. The same applies to AI. I see so many people jumping straight into ChatGPT or trying to build complex models without understanding what's actually happening under the hood. And you know what happens? They get stuck, frustrated, and eventually give up. So what are the basics? Simple. Just understand the real meaning behind these fancy words: AI, machine learning, neural networks, Gen AI, agentic AI, and LLMs, etc. Then see how they actually work and what their top 3 use cases are. Let me break this down for you. Artificial intelligence is basically teaching computers to think and make decisions like humans. Imagine you're teaching a child to recognize animals. You show them pictures, explain the differences, and eventually they can identify a dog from a cat on their own. That's essentially what we're doing with AI, but with machines. Machine learning is a subset of AI where computers learn from experience without being explicitly programmed for every scenario. It's like learning to ride a bike. Nobody can explain exactly how to balance, but through practice and experience, your brain figures it out. Machine learning works the same way with data. Neural networks are inspired by how our brain works, layers of interconnected neurons passing information. Think of it like a relay race, where each runner passes the baton to the next, and by the end, you get a result. Generative AI is the cool stuff you see nowadays, AI that creates new content. It's like having an artist who studied millions of paintings and can now create original artwork in any style you want. LLMs, or large language models, are AI systems trained on massive amounts of text to understand and generate human-like language. ChatGPT is an LLM. It's like having someone who's read the entire internet and can have a conversation about anything. Agentic AI takes it further. These are AI systems that can take actions, make decisions, and work autonomously to achieve goals. Think of it as the difference between a calculator, you tell it exactly what to do, and a personal assistant. You give it a goal and it figures out the steps. Now, I know many people have heard these words before, but most of them don't actually know how they work and where we use them. It's sad but true. They throw around terms like neural networks and transformers at parties to sound smart, but can't explain what they actually mean. Don't be that person. Spend a week or two really understanding these concepts. Watch videos, read articles, draw diagrams. Make it click in your head. Real-world use cases? AI is everywhere. It's in your phone's face unlock, computer vision, in Spotify recommendations, recommendation systems, in Google Translate, natural language processing, in self-driving cars, reinforcement learning, and in fraud detection at banks, anomaly detection. Once you understand what each type of AI does, you'll start seeing it everywhere, and suddenly, the world makes more sense. So once you are done with it, move into the next step, which is Step 2. Python, AI's main language. Now, don't worry, you don't need to learn the whole Python language and become an expert. Just learn and understand the basic syntax, like print, variables, if-else, then loops, functions, lists, dictionaries, and working with data using NumPy and pandas. Let me tell you something important. Python is to AI what a paintbrush is to a painter. It's your tool. And the beautiful thing about Python is that it's designed to be readable and simple. If you can read English, you can read Python. Seriously. Don't worry, it looks complicated and complex, but they are simple and easy to learn. Even Python is the simplest coding language. Here's what you actually need. Variables are just containers for storing information, like boxes where you put stuff. If-else statements are decision makers. If it's raining, take an umbrella. Else, wear sunglasses. That's literally how if-else works in code. Loops are repetitive tasks. Imagine you have to send the same email to 100 people. You wouldn't write it 100 times manually, right? You'd write it once and loop through your contact list. That's what loops do in programming. Functions are reusable pieces of code. Think of them like recipes. Once you write a recipe for chocolate cake, you don't need to rewrite it every time you want to make a cake. You just follow the same recipe. Functions work the same way. Lists are ordered collections of items, like a shopping list. Dictionaries are like real dictionaries when you look up a word, key, and get its meaning, value. In Python, you might have a dictionary of student names and their grades. Now, NumPy and Pandas are your data manipulation superpowers. NumPy lets you work with numbers and arrays super efficiently. Think of it as Excel on steroids, but faster and more powerful. Pandas helps you organize and analyze data in tables just like Excel spreadsheets, but with way more capabilities and speed. Write small programs and get comfortable. Start with something simple, maybe a program that asks your name and says hello, then move to a calculator, then maybe a quiz game. Build your confidence line by line, program by program. Here's a secret. You don't need to memorize everything. Professional developers Google stuff all the time. What matters is understanding the logic and knowing what's possible. The syntax, that comes with practice. Spend about 2 weeks here. Code every single day, even if it's just for 30 minutes. Consistency beats intensity. If you're finding this valuable so far, hit that like button. It genuinely helps more people discover this roadmap. Okay, let's keep going and move into the next step, which is Step 3, Machine Learning. This is where actual AI learning starts. Here, you learn about algorithms that help machines predict things, and you understand how machines learn from data. This is the moment where things get real. This is where you stop being a spectator and become a player in the AI game. Machine learning is the backbone of most AI applications today. Here's the big picture. Machine learning is about finding patterns in data and using those patterns to make predictions. Imagine you're a detective looking at past crime data to predict where the next crime might happen. That's machine learning in action. Here are some main basic topics you must learn about: supervised learning versus unsupervised learning, linear regression, classification, clustering, overfitting, train-test split, model accuracy, and evaluation metrics. Let me explain these in human terms. Supervised learning is like learning with a teacher. You show the machine examples with answers, labeled data, and it learns the pattern. Then it can identify new images on its own. Most of AI today uses supervised learning. Unsupervised learning is like exploring without a teacher. You give the machine data without labels and let it find patterns on its own. It's like giving someone a pile of mixed fruits and asking them to organize them without telling them what categories exist. The machine might group them by color, size, or shape. It's discovering the patterns itself. Linear regression is predicting a continuous number, like predicting house prices based on size, location, and features. You're drawing a line or curve through your data points and using that line to predict future values. It's like saying, based on past trends, if someone studies 5 hours, they'll score this much on the test. Classification is putting things into categories. Is this email spam or not? Is this tumor benign or malignant? Will this customer buy or not? It's all about drawing boundaries between different classes in your data. Clustering is grouping similar things together without being told what the groups should be. Netflix uses this to group users with similar viewing habits. Amazon uses it to group products that are often bought together. It's pattern recognition at its finest. Now, here's something crucial: overfitting. This is like a student who memorizes answers instead of understanding concepts. The model performs great on data it has seen, training data, but fails miserably on new, unseen data. It's one of the biggest challenges in machine learning. That's why we do train-test split. We hide some data from the model during training and use it later to see if the model can actually generalize or if it just memorized. It's like a practice test before the real exam. Model accuracy and evaluation metrics tell you how good your model is. But here's the thing: accuracy alone can be misleading. If 95% of emails are not spam, a dumb model that labels everything as not spam would be 95% accurate, but completely useless for catching actual spam. That's why we use multiple metrics like precision, recall, and F1 score to truly evaluate performance. Learn all the basics here. Work with real data sets. Maybe predict house prices, classify flowers, or analyze customer behavior. Get your hands dirty with the data. Once you're done with it, move into the next step, which is Step 4, Deep learning, or neural networks. This is the advanced version of machine learning. It helps in building smarter AI models that understand images, sound, and text. If machine learning is like learning basic math, deep learning is like learning calculus. It's more complex, more powerful, and honestly, more exciting. This is where the magic happens, where computers can recognize your face, understand your voice, translate languages, and even drive cars. You'll learn concepts like neural networks, layers, neurons, activation functions, convolutional neural networks, CNNs, transformers, backpropagation, training loops, overfitting and regularization, etc. Let me paint a picture for you. Imagine your brain processing information. When you see a cat, your eyes capture the image, different parts of your brain process different features, edges, shapes, colors, patterns, and eventually your brain says, "That's a cat." Neural networks work similarly, with layers of artificial neurons processing information step by step. Layers are stages of processing. The first layer might detect simple edges and lines. The next layer combines these into shapes. The next recognizes parts like ears and whiskers, and the final layer says, "cat." Each layer builds on the previous one, getting more sophisticated. Neurons are the basic processing units. They take inputs, apply some math, and pass the output forward. Activation functions decide if a neuron should fire or not, adding non-linearity so the network can learn complex patterns. Think of it like a series of filters, each one refining the information a bit more. Convolutional neural networks are specialized for images. They're inspired by how our visual cortex works, scanning images in small patches rather than looking at everything at once. This is why your phone can recognize faces in photos, or why doctors use AI to detect tumors in X-rays. Transformers, these are the architecture behind ChatGPT, BERT, and most modern language models. They're revolutionary because they can pay attention to different parts of the input simultaneously. When you read, "The animal didn't cross the street because it was too tired," your brain knows "it" refers to the animal. Transformers can understand these relationships too, through something called the attention mechanism. Backpropagation is how neural networks learn from mistakes. Imagine shooting arrows at a target. After each shot, someone tells you you're too far left or too high, and you adjust. Backpropagation works the same way. The network makes a prediction, measures how wrong it was, and adjusts its internal parameters to do better next time. Training loops are the iterative process of showing the model data, letting it make predictions, calculating errors, and updating the model. Repeat this thousands or millions of times until the model gets good. Overfitting and regularization. We talked about overfitting before, but in deep learning, it's even more critical because these models are so powerful they can memorize entire data sets. Regularization techniques are like adding rules to prevent this. It's like telling a student, don't just memorize, understand the underlying principles. Also, learn to use tools like PyTorch or TensorFlow to build image and text models. PyTorch and TensorFlow are frameworks that make building neural networks way easier. Think of them as pre-built construction kits. Instead of manufacturing every single Lego piece from scratch, you get the pieces and just assemble them into whatever you want. These frameworks handle the complex math and let you focus on designing the architecture. I know it all sounds scary, but trust me, it's just one step at a time. Here's the truth. Deep learning isn't about being a genius. It's about patience, practice, and persistence. Start with simple tutorials. Build a digit recognizer, MNIS dataset, then move to image classification. Then try transfer learning, where you use pre-trained models. Each small win builds your confidence. The beauty of deep learning is that you'll see results visually. You train a model on cat and dog images, and suddenly it can tell them apart. That moment when your model works, when it actually learns, is absolutely addictive. It's like watching your child take their first steps. When you're done with that, move into the next step, which is step 5. Projects. Yes, you heard that right. This step is important and crucial because this is where you actually build AI, even simple ones. Let me tell you something that most courses won't tell you. All the theory in the world means nothing if you can't build something real. Projects are where learning becomes skill. It's the difference between knowing how to play guitar chords and actually performing a song in front of people. You can build image classifiers, cat versus dog, voice-to-text models, sentiment checkers, positive or negative, fake news detectors, and personal recommendation systems. Let's talk about each of these. Image classifiers. Start simple. Train a model to distinguish between cats and dogs, or recognize handwritten digits. Then level up. Maybe build something that recognizes different types of food, classifies skin conditions, or identifies plant diseases. Real-world applications are everywhere. Farmers use image classifiers to detect crop diseases. Doctors use them to analyze medical scans. You're learning a skill that literally saves lives. Voice-to-text models. This is speech recognition. Every time you use Siri, Alexa, or Google Assistant, this technology is at work. Build a simple model that converts your voice commands to text. It doesn't have to be perfect, but building it teaches you about audio processing, feature extraction, and sequence modeling. Sentiment checkers. This is huge in business. Companies analyze millions of reviews, tweets, and comments to understand how people feel about their products. Build a model that can read text and determine if it's positive, negative, or neutral. Train it on movie reviews or product feedback. Then test it on real-world data, like tweets about a recent event. You'll be shocked at how accurate it can get. Fake news detectors. In today's world, this is crucial. Build a model that analyzes news articles and identifies patterns common in fake news. Sensational language, lack of credible sources, emotional manipulation. It's AI for social good. You're literally combating misinformation. Personal recommendation systems. This is what Netflix, Spotify, and Amazon use to keep you hooked. Build a simple movie or music recommender. Use collaborative filtering. People who liked A also liked B, or content-based filtering. If you liked action movies, here are more action movies. It's incredibly satisfying to build something that actually understands preferences. You must convert your knowledge into real skill. Projects make everything stick, and practice makes perfect. Here's what projects teach you that courses can't. Problem solving under constraints. Real data's messy. Models don't work the first time. You'll spend hours debugging why your accuracy is stuck at 60%. You'll learn to clean data, handle missing values, deal with imbalanced data sets, tune hyperparameters, and most importantly, you'll learn persistence. And here's a pro tip. Document your projects. Write about what you built, what challenges you faced, how you solved them. Create a GitHub repository, write a blog post, record a video explanation. This becomes your portfolio, your proof that you don't just consume content, you create solutions. Okay, so here comes the next step. Today's AI wave. Step 6, Gen AI, tools and LLMs. Here you connect your knowledge to modern Gen AI and learn to create content using models and tools like ChatGPT for text generation, Midjourney for AI images, Runway for AI videos, and 11 Labs for AI voices. This is where you join the present, the cutting edge, the stuff that's changing the world right now as we speak. Everything we've learned so far, it all culminates here in generative AI. Think about it. Just 3 years ago, AI could recognize cats in images. Today, AI can create entire images, videos, music, and conversations from scratch. That's the power of generative AI. We've moved from AI that understands to AI that creates. You'll learn how to create real-world AI outputs without coding and get to know how large language models, embeddings, and prompt engineering work. Large language models like GPT-4 are trained on trillions of words from books, websites, papers, and conversations. They understand context, nuance, and can generate human-like text. But here's the fascinating part. They don't just memorize, they learn patterns in language itself. That's why they can write poetry, debug code, explain quantum physics, and even joke around. Embeddings are how AI represents meaning mathematically. Every word, sentence, or image gets converted into a series of numbers, vectors, that capture its meaning. Words with similar meanings have similar number patterns. This is how AI knows king relates to queen the same way man relates to woman. It's all in the math. Prompt engineering is the art of talking to AI. It sounds simple, but it's incredibly powerful. The same model can give you garbage or genius depending on how you ask. It's like the difference between asking, "Tell me about history," versus "Explain the fall of the Roman Empire," like a curious 10-year-old focusing on the economic factors and using modern examples. The specificity, context, and structure of your prompt determines the quality of the output. Use APIs to build small apps, chatbots, PDF Q&A bots, content generators, etc. This is where you become an AI builder, not just a user. APIs, application programming interfaces, let you plug AI capabilities into your own applications. Want to add AI to your website? Use an API. Want to build a chatbot for your business? API. Want to create an app that summarizes research papers? API. Build a chatbot that answers questions about your company, your products, or even yourself. Build a PDF Q&A bot where you upload any document and ask questions about it. The AI reads it and answers. Imagine uploading your entire textbook and having an AI tutor that knows everything in it. Build content generators, maybe a tool that writes social media posts, creates product descriptions, or creates email responses. The possibilities are endless, and the barrier to entry is lower than ever. You don't need a PhD or a supercomputer. You need curiosity, basic coding skills, and access to APIs. Most companies offer free tiers to get started. Get some hands-on experience with modern AI tools. Use ChatGPT for brainstorming, coding help, content creation, learning assistance. Use Midjourney or DALL-E to create stunning visuals for your projects. Use Runway to experiment with AI video editing. Imagine creating entire video sequences from text descriptions. Use 11 Labs to clone voices or create realistic narration for videos. But here's the deeper lesson. Don't just be a tool user. Understand what these tools are doing under the hood. When you use ChatGPT, you're interacting with a transformer model trained on billions of parameters. When you use Midjourney, you're leveraging diffusion models that learned to denoise images. When you use these tools with understanding, you can push them further, troubleshoot problems, and even build your own versions. Then move into the final step, which is Step 7. Specialize in a niche and build a portfolio. Instead of trying to learn everything and master all, pick one track and become an expert in it. Let's say you focus on becoming AI engineer or ML engineer, data scientist with strong ML, Gen AI expert, LLMs, and AI agents. Here's a hard truth. In today's world, being a jack of all trades makes you master of none. The AI field is vast. You cannot be equally good at computer vision, natural language processing, reinforcement learning, robotics, and generative AI. It's just not humanly possible. And you know what? You don't need to be. Specialization is your competitive advantage. It's your moat. It's what makes you valuable and irreplaceable. AI engineer or ML engineer, these are the people who build, deploy, and maintain AI systems in production. They don't just train models in notebooks, they create scalable, reliable AI applications that handle millions of users. They know about model optimization, deployment pipelines, monitoring, A/B testing, and cloud infrastructure. If you love building systems, solving engineering challenges, and seeing your code impact real users, this is your path. Data scientist with strong ML. These professionals combine statistical analysis, business understanding, and machine learning to derive insights and build predictive models. They answer questions like which customers are likely to churn, or what factors drive sales, or how can we optimize our pricing. They're storytellers with data, translators between business needs and technical solutions. If you enjoy analyzing patterns, communicating findings, and influencing business decisions, this is your calling. Gen AI expert, LLMs, and AI agents, this is the cutting edge right now. These experts build applications using large language models, create AI agents that can take actions, and develop innovative solutions in the Gen AI space. They might build custom chatbots, AI writing assistants, code generators, or multi-agent systems that collaborate to solve complex problems. If you're excited by what's new, want to ride the current wave, and love experimenting with emerging technologies, this is where you thrive. Do whatever aligns with your nature, interests, and hobbies. It will boost your confidence and make you irreplaceable. Think about it. What excites you? Do you get lost scrolling through creative AI art? Maybe specialize in generative models. Are you fascinated by self-driving cars? Dive into computer vision and reinforcement learning. Do you love analyzing data and finding insights? Data science might be your thing. Does building products that people use excite you? AI engineering is calling your name. Your interests matter because AI is hard. The learning never stops. New papers drop daily. Techniques evolve. If you're not genuinely interested, you'll burn out. But if you love what you specialize in, it won't feel like work. It'll feel like play. Build a portfolio that showcases your specialization. If you're into computer vision, have 5 to 10 projects demonstrating your skills. Object detection, image segmentation, facial recognition, medical imaging. If you're a Gen AI specialist, showcase chatbots, content generators, AI agents, and custom applications. If you're a data scientist, showcase end-to-end projects with business context, analysis, visualizations, and model deployment. Your portfolio is your proof. Anyone can claim they know AI, but when you show working projects, documented code, write-ups explaining your process, and actual results, you become credible, you become hireable, you become valuable. Share your work on GitHub, write technical blogs on Medium or your own site, create YouTube tutorials, contribute to open source projects, build in public. It's scary at first, but it accelerates your growth exponentially. You learn faster when you teach, you get feedback, you build a network, opportunities find you. Final thoughts. Okay, so now you have a complete, powerful roadmap with 7 steps to follow one by one, and I bet you'll understand more than 90% of people out there. AI isn't complicated, it's just a clear roadmap, and to be honest, I'm learning AI the same way I just told you, and trust me, it's effective, efficient, and gives you a clear direction toward the world's most powerful technology, AI. Here's what most people don't tell you. This journey takes time. It's not a 30-day challenge or a weekend boot camp. It's months of consistent effort. Some days you'll feel like a genius when your model finally works. Other days you'll want to throw your laptop out the window because nothing makes sense. Both are normal. Both are part of the journey. The difference between people who make it and people who quit is consistency. Not talent, not genius, just showing up every single day, even when it's hard, even when progress feels slow. Another thing, you'll never feel ready. There will always be more to learn, a new technique, a better approach, a paper you haven't read. That feeling of being overwhelmed, it never fully goes away. But here's the secret. You don't need to know everything to start creating value. You just need to know enough to solve the problem in front of you. The rest, you learn along the way. AI is the future, but more importantly, it's the present. It's transforming every industry: healthcare, finance, entertainment, education, transportation, agriculture, and we're still in the early innings. The opportunities today are unprecedented, but they won't last forever. In a few years, AI literacy might be as common as computer literacy. The time to learn is now. The time to build is now. So take this roadmap, customize it to your situation, and start walking. Don't wait for the perfect time. Don't wait until you feel ready. Start messy. Start imperfect. Start today. Hit like if you got help even a bit. Subscribe to get more simple breakdowns, roadmaps, and blueprints on similar topics. And share this with someone who is also learning AI with you. Stay sharp, stay safe.